Hello everyone, my name is Dr. Onyebuchi Joseph Mwandiobu. I held a PhD in environmental chemistry. I am as well a federal government designated food and drug public analyst and also an ISO IEC 17025-2017 lead assessor and tutor. And by the grace of God, I have led a public analytical lab that was accredited to ISO 17025. You're welcome to this channel where we simplify water, wastewater, and environmental laboratory analysis. In this fourth video, we are going to discuss in depth the principles of atomic absorption spectrophotometry, commonly known as AAS. Atomic absorption spectrophotometry finds application in water and wastewater analysis, soil and sediment analysis, food, drugs, geological samples, and a host of sample analysis. Now, what is AAS? Atomic absorption spectrophotometry, also known as AAS, is an analytical technique used in the determination of the concentration of different elements in different samples. It is widely used because of its sensitivity, selectivity, and reliability towards metal analysis. The basic principles of AAS relies on the absorption of light by free atoms at ground state. Here is how it works. Every metallic element absorbs light at a specific wavelength, characteristics of that particular element. In general, AAS analyzes only liquid sample, and that implies that if the sample is solid, the sample will be leached into solution by a process known as acid digestion. Now, if the liquid sample is introduced in the flame, there are four major things that happens in the flame. The first of it is evaporation of the liquid and leaving behind a solid residue. The second is vaporization of the solid residue and conversion into gaseous molecule. The third of it is atomization or dissociation of the gaseous molecule into free atoms at ground state. The fourth of it is absorption of light from a line source, which is a hollow cathode lamp. Now, the amount of light that is being absorbed is measured by the instrument and by the principle that the machine relies on or the technique relies on, which is Beer-Lambert's law. The amount of light that is absorbed is proportional to concentration of the elements in the sample. Now, what does this imply? If something is directly proportional to the other, what it means is that as one is increasing, the other one is increasing. This clearly shows that if the absorbance is increasing, the concentration as well is increasing. Now, we ask ourselves, why is AAS element specific? It is clear to understand that each element has a unique electronic structure. And because of the unique electronic structure of each individual element, that is why each of them has a wavelength where it absorbs. And this wavelength is different from every other element. For example, lead shows absorption at 283.3 nanometers. At this particular wavelength, no other element will absorb light at that wavelength. Now, what are the key advantages of atomic absorption spectrophotometer? One of it is high selectivity for trace elements. The second of it is good accuracy. The third of it is reliable and simple operation. And the last part of it is that it has a wide applicability in different samples. Now, there is one major limitation of the application of atomic absorption spectrophotometer, and that is because it measures one element at a time, and this makes it difficult to analyze multi-elements at a time. Dear viewers, I thank you all for listening to our lectures today. In our next class, we will discuss in depth the operation of atomic absorption spectrophotometer. Do not forget to like, subscribe, and share this page. Thank you very much.